Hey guys, before we go on to other types of equations, we're going to look at some applications of those quadratic equations we talked about last time. So applications, also known as word problems, so of course everyone's favorite. But one thing about this section is they are applications of quadratic equations, so at least we know that the equation we're trying to come up with is going to be a quadratic equation. And that's the hard part, right? Coming up with equations. So I just have a few examples for us to go through. And that's the other hard part, is because all applications are so different. There's such a varied approach to them. But there are a couple of things that we need to know. And one is this idea of, what does it mean when your problem talks about consecutive integers? Okay, consecutive means things falling right in a row. So if you're talking about consecutive numbers, right, integers, then 5, 6, 7, 8, 21, 22, 23. So numbers right in a row. So algebraically, if you're looking for 2 or 3 or 4 numbers that are consecutive, that fall one after the other, and we don't know what they are, then of course the first one we'll just call x. But the very next number, if our first number is x, the next number would be x plus 1. And then the next one would be x plus 2 and x plus 3, etc. So anytime we see a problem talking about consecutive integers, I know how to write my variables. If we're talking about consecutive odd or even, it works the same way. Then if our first number is x, the next one would be x plus 2, and the next one would be x plus 4, right? To jump to either that next odd or even number. If this number is 6, then this one would be 8, and then 6 plus 4, 10, 6, 8, 10. Or if this number is 7, this one would be 9, 7 plus 2, etc. Okay, so additionally, there's a formula that we'll need to know to work some of these problems. But if you remember anything from your high school math classes, it's probably this formula, the Pythagorean theorem, right? So don't forget that the Pythagorean theorem is a squared plus b squared equals c squared. And anytime I'm dealing with a right triangle, then I can think about the Pythagorean theorem where the hypotenuse is c. It doesn't matter which of these legs is a and b, as long as we always have the hypotenuse as c. Okay, so now that we've refreshed our memory about those items, let's work a few examples. Find 2 consecutive integers whose product is 56. Okay, it wants me to find 2 consecutive integers. So I know, just because of knowing what it means to be consecutive integers, those numbers are x and x plus 1. There's my 2 consecutive integers. Now, whose product? Oh, that means I want to multiply these two things. Product means multiplication. Whose product is always an equal sign. Whose product is 56. There's 2 consecutive integers whose product is 56. And now I have an equation. I just need to solve it. First thing I got to do is get rid of these parentheses. So let's distribute that x. So x squared plus x equals 56. Since I wound up with a quadratic equation, because I'm in this section, I feel pretty comfortable with that. I know I'm looking for quadratic equations. But since I wound up with a quadratic equation that I cannot use the square root method on, the first thing I'm going to try to do then is factor it. So that means it needs to be set equal to 0. So I'm going to subtract 56 from each side. And then I need 2 numbers that when you multiply them together, multiply and give negative 56. And when you add them, add to give 1, right? Because this number in here is a 1. So that means, and again, I got to be good at factoring, but because our leading coefficient is a 1, we get that shortcut for our factoring. So my numbers are 8 and negative 7. So I can just put them right into my factors. Positive 8 and negative 7. Okay, now I can use my zero product property. I have two things that when you multiply them together equal 56. So that means equal 56. It does not equal 56. Equals 0. So that means that one of those things has to be 0, right? Has to be 0 at least. So I'm going to write this at least one more time. That means x plus 8 equals 0 or x minus 7 equals 0. Okay, simple linear equation. If we subtract 8 from both sides, we have x is negative 8. Or if we add 7 to both sides, x is 7. Now, these numbers are not consecutive. So these are not my final answer. Make sure to answer the question. I'm looking for two consecutive integers. My consecutive integers are x and x plus 1. So if x is 7, that means x plus 1 is 8. So there's one pair of consecutive numbers. Likewise, if x is negative 8, x plus 1 is negative 7. So here's my other pair of consecutive integers that multiply and give 56. Okay, this one's talking about the sum of the squares of two consecutive odd integers. Well, at least there's two consecutive odd integers, so I know I'm talking about x and x plus 2. That's my two consecutive odd integers. Is 202. Now I got to figure out what this means. Sum means adding. So this time instead of a product, right, I'm going to sum these integers. But not just the sum of the integers, the sum of the squares. So I need to square these integers, right? Now this is the sum of the squares of two consecutive odd integers. And that is 202. And voila, there we have our equation again. So all I have to do is solve this quadratic equation, which first step means get rid of these parentheses. So again, if we're good at factoring, we should also recognize this as a perfect square trinomial that I know how it multiplies out. Now, if I want to go over to the side and write this as x plus 2 and do your distributive property or your FOIL and multiply it out, that's fine. But also, we're going to use this quite a bit, so it's handy to know that shortcut for multiplying out a perfect square trinomial. You square the first one, you multiply the two terms together, which would give 2x, and double it, and then you square that last term. Okay, so however you want to get to that. Then again, it is a quadratic equation, so I can't use the square root property on it, so I'm going to set it equal to 0 and try to factor it. So I'm going to combine these like terms to get 2x squared plus 4x, and since it needs to be set equal to 0, I need to subtract 202 from both sides. So that would give me minus 198. Okay, I noticed the size of these some of these numbers anyhow might be a little daunting. So I'm going to, anytime I'm factoring, one thing I'm also going to try to do is make my numbers as small as possible, right? So I notice they're all even. Let's divide everything by 2, right? Make my numbers smaller so that I wind up with x squared. Hey, that's also going to make my factoring easier when that leading coefficient is 1. Plus 2x minus 99, and 0 divided by 2 is still 0. Okay, so now I'm still trying to factor, looking for two numbers that when I multiply them give me negative 99, because negative 99 times 1, and when I add them give me 2. What about 11 and 9? So I've got x plus 11 and x minus 9. get our factoring down, guys. If you're having trouble factoring, you gotta work on that. Okay, so now that means that one of these at least is 0. So either x plus 11 is 0 or x minus 9 is 0. So that means, now let's see if we can start consolidating some steps and go right to, if we know x plus 11 is 0, I know I'm going to subtract 11 from both sides, so I've got a negative 11, and over here a positive 9. Once again, these are not my consecutive numbers, so my consecutive numbers in this case are x and x plus 2 because they were consecutive odd. Okay, so if x is negative 11, x plus 2 is negative 9. Likewise, if x happened to be 9, then x plus 2 is 11. Okay. A piece of machinery produces rectangular sheets of metal such that the length is 3 times the width. Equal size squares measuring 5 inches on a side can be cut from the corners so that the resulting piece of metal can be shaped into an open box by folding up the flaps. If specifications call for the volume of the box to be 1,435 cubic inches, find the dimensions of the original piece of metal. The first thing you need to do when we're working these application problems is make sure we understand what the English is saying, right? There wasn't much English in the previous 2 examples, but the English is what gives us difficulties. So read it however many times it takes you to understand, but I know that they said that I'm going to have this rectangular piece of metal, okay, where the length is 3 times the width. So if this is the width of the piece of metal, then the length is 3 times that, right? It didn't tell us what the width was. It just told us the length was 3 times that. Now we're going to cut squares 5 inches on the side from the corners. So let's imagine if we cut squares off of all the corners, that are 5 inches on each side, each square 5 inches on the side. It'll look like this. And that's so that if we can imagine now folding these flaps up, this flap, this flap, this flap, it's going to make an open top box. Okay. So if specifications call for the volume of the box to be, the volume of the box is 1,435, right? Then that's all the information it gives us. It asks us to find the dimensions of the original piece of metal. So I also need to know the formula for volume is length times width times height. Okay, so here's my volume of my box. So let's substitute in what we know for this box here that we're making. So we know the volume is 1435, so I'm going to replace this V with 1435. Okay, now the length of the box, remember, here's the length of the box. Okay, the length of the piece of metal is 3W, but the length of the box is only this long, so it's 3W. If I take away 5 from this end and 5 from this end, it is 3W minus 10. Okay, the length. Now the width of the box is only this piece because it's the width of the box, not the whole piece of metal. So the whole piece of metal is W, but if I take away 5 and 5 again, And then I have W minus 10. Now the height of the box is this right here, the flap that folds up. So the height of the box is 5. There's our equation. Okay, volume equals length times width times height of the box. Okay, so I'm going to flip this around as I multiply this out. So I'm going to multiply these out. I'm going to put that 5 in the front of my equation just because that's normally the way we want it. I'm going to distribute here to start getting rid of parentheses. So 3w squared minus 30w okay, minus 10w plus 100 gets those two binomials multiplied together. Okay, so now I have 5 times this, now equals 1435. Now my next step could be to distribute this 5. But notice, just like on that last one, oh, I'm hoping I can make my number smaller because I don't really want to work with that number. Hey, that number is divisible by 5. Let's divide this 5 out of both sides. I can only do that because this is being multiplied. Okay, so if I divide this side by 5, that gets to cancel out. Let's go ahead and combine these as we're going, right? That's going to be minus 40w. Plus 100 equals, now I got to divide this by 5. So what is that? 2, let's see, 5 goes into 14, so 243, 287. Okay, now it's a quadratic equation. I'm going to try to factor it. So I need it set equal to 0. So let's subtract 287 from both sides. So minus 187. And at this point, I would try to see also if I could get rid of that 3, right? But it's pretty easy to see that 3 doesn't go into 40, so it doesn't really matter if it goes into 187 or not. Okay, so this one might be a little bit more difficult to factor, so maybe I want to put up my actual chart over here. And let's see, that means I need two numbers that multiply and give whatever 3 times negative 187 is. So I know that's going to be negative. So 3 times 7, 21. Let's see. 561. I'm going to check myself here just so we don't go too far astray. 561. And that adds to give negative 40. Okay, so let's see if I can think of things that multiply to give 561. I'm going to say, what is 561 divided by 11? Ooh, only because I know my rules for 11, right? If these two numbers add to give that middle number, then it's a factor of 11. And I did come up with 51. So if I used negative 51 and 11, that's going to be the numbers I'm looking for. Okay, got to practice that factoring. And the more you do it, the easier it is to come up with the numbers you need. All right, so that means now that we can replace negative 40w with negative 51w plus 11w minus 187 equals 0. That means these things are perfect square trinomials. So I can factor 3 out of these two. That's going to leave w squared minus 17. It's not going to leave w squared, is it? Get a factor out of 3w. 3w, because they both have a w. And so that's going to leave w minus 17. Over here I can factor out that 11. Look, same thing. 1 and 7 is 8. If there's an 8 in the middle, that thing's divisible by 11. And that's going to leave w minus 17. So I wind up with w minus 17 times 3w plus 11 equals 0. That means that either w minus 17 equals 0 or 3w plus 11 equals 0. So w is 17 or w is negative 11/3. Now, because of the nature of this question, and we're trying to find the lengths, the dimensions of this piece of metal, a length cannot be negative. So that's what we call an extraneous solution, right? We can disregard it. That means the width must be 17. Make sure you answer the question. Does it want the width of the box? The width of the original piece of metal? And this says find the dimensions of the original piece of metal. And the original piece of metal was actually W. So far we have that, and it is inches. We need that. And so then the length is 3 times W. So 3 times 17 is 51. So that original piece of metal, not the dimensions of the box, must be 17 by 51. Okay, a piece of property has the shape of a right triangle. Woohoo, right? If we know it's a right triangle, we've got that Pythagorean theorem that we can use. So I've got this right triangle here. All right. The longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangular log. All right, so we've already got our triangle drawn. The longer leg, so let's call this one the longer one. Doesn't matter which, these are both legs, doesn't matter. The longer leg is 20 meters longer than twice the length of the shorter leg. Instead of calling this S for the shorter leg, I'm going to call it X just because that's going to look like a 5 in a minute. Right? Could look like a 5. So let's call this shorter leg X. Okay? So the shorter leg is X. Okay? The longer leg is 20 meters longer than twice X. So that's twice X plus 20. The hypotenuse is 10 meters longer than the longer one. If this is the long one, the hypotenuse is 10 longer, so the hypotenuse is 2x plus 20 plus 10, so plus 30. Okay, then it just says find the lengths. That's all I need to know, because I know if this thing is a right triangle, I've got a squared plus b squared equals c squared. So a squared plus b squared oh my goodness, plus b squared equals c squared. A, B, C. Okay, quadratic equations. You got to get rid of those parentheses. Here we are again, having to multiply out that perfect square trinomial. So it saves us some work if we know that shortcut, which is Square the first term. Multiply everything together, so that would be 40x, and then square it, and then double it. 40x would make it 80x, and then square the last one. Same thing here. Square the first term, multiply everything together, which would be 60x, and double it, and then square the last one. Okay, now I need to put everything on the same side, set it equal to 0, see if I can factor it. Okay, notice if I subtracted 4x squared from both sides, that's just going away. So that's great. I just have an x squared. That'll make my factoring easier. Let's subtract 120x to combine these terms. Right, so that's gone. That's negative 40x. And then if we subtract 900 from both sides, we have negative 500 equals 0. Okay, so I'm going to try to factor this. I am looking for two numbers that multiply to give negative 500 and add to give negative 40. Those numbers are 50 and 10. Once again, that just comes with practice, right? 50 times 10. Okay, one of them needs to be negative, so I've got x minus 50. The biggest one needs to be negative. X plus 10 equals 0. Okay, so that means that at least one of those values have to be 0. So either x minus 50 is 0 or x plus 10 is 0. So x is 50 or x is negative 10. Once again, these are the lengths of the sides of that triangle. So a length can't be negative. Now, let's make sure we answer the question. Find the lengths of the sides of the triangular lot. Okay, so there's one side. Another side is 2x plus 20, and these are in meters, so I need that. Okay, and the other side, that was the shorter side, so the longer side is 2 times 50, right? 120. And the hypotenuse is 2 times 50, 130. Okay, great. It's these kind. These kind are easy because one of the most difficult parts is coming up with that actual equation, and this one's just going to give us the equation, right? So if a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height s, okay, so the height is s, right? In feet above the ground, t seconds, so the t, this is the time, right? Time. After projection is given by this. So after how many seconds will it be 50 feet above the ground? Okay, after how many seconds will it be 50 feet above the ground? So the 50 feet is the height, right? So S needs to be replaced with 50. So I'm just going to put a 50 right there. We're looking for how many seconds. We're looking for the second, so that t is going to stay. So 50 equals negative 16 t squared plus 100 t. And there's my quadratic equation. So I do not like the leading coefficient to be negative. So instead of moving this over here to set it to 0, I'm going to move both of these in this direction to give us positive 16t squared minus 100t, okay, plus 50 equals 0. Okay, once again, my numbers are quite large, so let's see. I know they're at least even. I can cut them in half. 50 is not divisible by 4 or 8, so I can't go any further. But let's divide everything by 2 at least. Get a little bit of help there. 8t squared minus 50t, okay, plus 25 equals 0. Okay, so now I need two numbers that multiply. 8 quarters is 200, right? That multiply to give 200, but add to give negative 50. All right, so let's try 20 and 10. It's 30. Okay, how about 25 and 8? That's not it. 25 and 8. 33. So one thing I can do, once again, practice that factoring. Let's take these first two numbers I came up with and change it into all its factors. That's 20, right? And then that's 10. So that's the 4. So now I can see everything. There's my 10 times 20, 25 times 8. I could do 4 times 50, but 4 times 50 is 54. It's looking like this thing won't factor. Okay, so if it doesn't factor, I can complete the square. But completing the square is going to make a fraction. So this is a quadratic formula equation. All right, so let's plug it into the quadratic formula. X equals negative b, so negative 50, plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, so x equals 50 plus or minus, it really didn't give us room to work this one, did they? Negative 50 squared, so 2,500 minus, now 4 times 25 is 100, so 100 times 8, 800. I'll just have to use up the rest of this room down here and we can erase it. Okay, so x equals 50 plus or minus 2,500 minus 800, 1,700 all over 16. Okay, this I got to simplify, and that's 100 times 17, and I've chose 100 because I can easily do the square root of 100. So the square root of 100 is 10. Again, those radicals, something that if you're not great with, that's prerequisite information. So you need to go back maybe and practice up on that. Okay, now notice they're all divisible by 2. So I can simplify that even further. Divide a 2 out of each term so that I get 25 plus or minus 5 square roots of 17 divided by 8. Now, if we were just solving a quadratic equation, this is what our solution would look like. However, in this case, since we're asked a question, right, about how many seconds, we're not going to tell someone, oh, put the microwave on for square root of 17 seconds, right? So we're going to, and the only way we're going to get this solution is plug it in our calculator. Now, for the most part in this course, we're not supposed to be using a calculator, but when we have a case like this, we don't have a choice. So let me, okay, in my calculator, and I'm just going to plug that in my calculator. Remember, if I plug it in my calculator, I've got to put parentheses around this. And this in here is automatically going to put one parenthesis, so don't forget to close that one and then put an extra parenthesis. You got to have parentheses around that numerator. So 25, let's do the plus one first. Plus 5, remember there's two answers here. Plus 5 times the square root of 17 divided by 8 is 5.7. On and on and on. I'm going to round to the nearest tenth. So 5 point. Okay, so one of them is 5.7. And feet, right? And the other one, if I put a minus in there, is 0.54 feet, 0.55 actually, if we're going to round to, let's round to the 10th, let's make it 0.5. So you might be asking, why do I have two answers in this one? These are both perfectly valid. Think about what happens when you shoot a projectile up into the air, and then it's going to come back down. Okay, so let's say this is 50 feet above the ground. Well, it took it, no, we're looking for 100 feet per second, 5.7, that's not feet, that's seconds. .7 seconds. Okay, so it took it a half a second to get right here, and then it traveled on, and in 5.7 seconds, it was falling, and it was at 50 feet again. Okay, let's look at the last one. How long will it take for the projectile to return to the ground? Oh, a return to the ground, that means the feet is 0, right? Because it's on the ground. So I'm going to put a 0 in here. Okay, we'll go ahead and do that. Negative 16 t squared plus 100 t. Okay, once again, I'm going to move everything to this side to set it equal to 0 because we don't want our leading coefficient to be negative. So if I add 16t squared to both sides and I subtract 100t from both sides, okay, now hey, this one I can factor, right? Let's make our numbers smaller still by dividing them by 4. I can do it now or I can do it later. Let's divide everything by 4. So I get 4t squared minus 25t equals 0. So I can factor out a t, and that's going to leave 4t minus 25 equals 0. That means either t equals 0 or 4t minus 25 equals 0. So the first time is 0 seconds. When is it going to be on the ground? At 0 seconds. It starts on the ground, right? And then this would be 25 fourths. Once again, We're not going to say 25 seconds. So I need to simplify that to 6 1/4 seconds, or 6.25 seconds. So it'll go up and come back down in 6 1/4 seconds. It's going to be back on the ground. Okay, that does it for this section. I'll see you next time.